All right, so this is the key to the in-class activity, which was on absolute value equations and then absolute value inequalities. So in the first one, where we had the absolute value of 3x minus 5, and then we're subtracting 2 from that expression, and that left side is going to equal 6. So the way we want to solve this algebraically is we need to isolate this absolute value expression first. So right now I'm subtracting 2. The opposite is to add 2. So you're going to add 2 to both sides. Once you do the left, you have to do the right. And so I get the absolute value of 3x minus 5, and then a negative 2 and the opposite 2 are zeros, or negative 2 and opposite 2 are opposites, and when you add them up, you get 0. And then over here, 6 plus 2 is 8. Okay, now at this point, once you get to this point, you need to write this as 2 separate equations without the absolute value bar. All right, so just like we saw when we had, let's say, a very simple example, the absolute value of x is equal to 5. So this is pretty easy to look at and then think about what the solution is. The absolute value of what number is 5? Well, one of the solutions is x must equal 5, because the absolute value of 5 is 5. 5 is 5 units from 0. The distance from 0 is 5. The other one is that the absolute value of negative 5 is also 5, because on the number line, negative 5, if you think about it, here's 0, here's negative 5, that distance from 0 is also 5. All right, so once you get to this point where the absolute value expression is by itself, then you want to rewrite this without the absolute value bars. It turns out that in this particular case, what we end up with are going to be linear equations. So it'll make things a lot easier for us. So when I rewrite this, I get 3x minus 5 is equal to 8, and then 3x minus 5 is equal to the opposite of 8. So these are linear equations, which now we can solve very easily. So let's deal with the first equation. So I'm going to add 5 to both sides, and then 5 and a negative 5 is 0, so I get 3x is equal to 13. And then to get x by itself, we're going to divide both sides by 3, because remember the opposite of multiplication is division. So the coefficient of x here is 3, so I'm going to divide both sides by 3. 3 divided by 3 is 1. 1 times x is x, so I get x to be 13/3. Now, if we're doing this correctly, this should be a solution. You don't really need to check, although it's always a good idea to check, because you could have made a mistake somewhere along the way. As long as the absolute value, the absolute value here, once you get it by itself, as long as the absolute value expression is equal to a positive number or 0, you're going to get a solution. If this was a negative 8, we talked about this in class, the absolute value of 3x minus 5 equals a negative 8, that would be no solution, because the absolute value of a number is either positive or 0. It is never negative. So remember, the absolute value of negative 8 is a positive 8, right? The absolute value of 0 is 0. The absolute value of 7 is 7. So notice all of these numbers right here, all of these numbers are positive or 0. They're never negative. Okay, now let's mentally check this. Well, let's actually check this, just to show you how to check this. So if you want to check that solution right here, you always go back to the original, because you could have messed up along the way. So if I go back to the original, 3x minus 5 minus 2 equals 6, and I substitute 13/3 in for x. So remember, I want to see if this left-hand side is going to equal 6. So I get 3 times 13/3 minus 5. So in place of x, I substituted 13/3. Whatever that is, I'm going to subtract 2, and I want to see if that's going to equal 6. Well, 3 times 13/3, the 3's divide out, so that's just 13 right here. And then 13 minus 5 is 8. I'm sorry, 13 minus 5 is 8. So I get the absolute value of 8 minus 2 and I want to see if that's equals 6. Well, the absolute value of 8 is 8, and 8 minus 2 does indeed equal 6. So this is going to be a solution. So 13/3 is a solution. Now let's solve for this equation. Again, this is linear, very easy to do now. I'm going to add 5 to both sides. The 5 and negative 5 is 0. Those are opposites. So I get 3x is equal to a negative 8 and a positive 5 is a negative 3. And so to get x by itself, I'm going to go ahead and divide both sides by 3 because the opposite of multiplication is division. 3 divided by 3 is 1. So I get x to be, and then a negative 3 divided by a positive 3 is a negative 1. And so I can check that one as well. So checking that one, again, always go back to the original. Don't go here because you could have made a mistake when you added 2 to both sides. So always go back to the original. So we have the absolute value of 3x minus 5 minus 2 equals 6. So in place of x this time, I'm going to substitute negative 1. So I want to see if 3 times a negative 1 minus 5, whatever that is, once I subtract 2, I want to see if that's going to equal 6. Well, 3 times a negative 1 is a negative 3. So I got a negative 3 and a negative or minus 5, subtract 2, and I want to see if that's equals 6. Well, a negative 3, remember subtraction right here is the same thing as adding the opposite. So this is really negative 3 plus a negative 5. So a negative 3 plus a negative 5 is a negative 8. So I get the absolute value of negative 8 minus 2. And the absolute value of negative 8 is 8, right? So 8 minus 2, which does equal 6. So negative 1 is also a solution. And so that's it. All right, so that was number 1. Notice the steps you had to go through, the procedure. Okay, now be careful with number 2. Don't confuse the setup between, see, this is a greater than absolute value. Don't confuse that with something like this. If this had been 2x, the absolute value of 2x minus 5 is less than or equal to 7. Those are two different inequalities. Algebraically, they're solved differently. Okay? So with a greater than, think of the or statement. With the less than, if this was a less than, you would think of an and statement, which would involve the intersection. With an or statement, you're dealing with a union. And you're going to see what that looks like when we do this. Okay, so we saw in class that the best way to think about, because some students do get these two confused with each other. So the best way to do that is to think of a simple example, like the absolute value of x is greater than 2, let's say. And so if you think about this, the absolute value of what numbers are greater than 2? Well, on the number line, if you think about it, the absolute value of what numbers are greater than 2, well, any number that is greater than 2, right? Just like this. So 2.78, 2.0001, 4.76, and so on. But we also notice that any number less than negative 2 is also a solution. Because the absolute value of negative 3, if we look at negative 3, the absolute value of negative 3 is 3, and 3 is bigger than 2. All right, so when you do the absolute value greater than, you got to think of this as, notice this part right here, 2 intervals. So when we write this in interval notation, it looks like this. Negative infinity to negative 2, parentheses. Now parentheses because there's no equal sign. Union, notice the union. We said union right here. Notice the union. Union 2 to infinity. When we broke this down, though, into two inequality symbols, this right here means this. X is less than 2 or x is greater than 2. That or statement. All right? Okay, so here's the way we're going to do this. So when trying to do this, think of a simple example. So just like we did here, when you get the absolute value by itself, you're going to rewrite this in, see how we wrote this in two separate equations? You're going to do this in two separate inequalities, but you have to make sure you use the R statement. The R statement, because this is going to be a union. So the first thing you're going to do is you're going to rewrite this first. You're going to put this part first. So what I mean is this. The absolute value of 2x minus 5 is greater than 7. You're going to do this. You're going to say 2x minus 5 is greater than or equal to 7. That's just right here. Or 2x minus 5. Now you can do the less than. And I forgot to put the negative right here. Negative. So now you can do the less than. I want you to notice that 2 and negative 2 are opposites. So see how this is a 7? You're going to say less than or equal to a negative 7. All right, so notice the expression that's within the absolute value bars. You're going to rewrite it without the absolute value bars. 2x minus 5, 2x minus 5. You're going to say greater than or equal to 7, and on this side you're going to say less than or equal to negative 7. Greater than, less than equal to 7, negative 7. You have to write like this. There's no other way to combine these two. Like some students when doing this one with this, what we learned in class was that for this one, we can write this in compact form. 2x minus 5 is likely to be 7, and then at the same time must be greater than or equal to a negative 7. You cannot write, we talked about this, and it's also in the instructional videos, you cannot write this greater than in compact form like this. You cannot write this to look like this. Okay? All right. Now, just like we did with the absolute value equations, you now have two linear inequalities. So we're going to solve each one, just like that. We're going to combine like terms. This is 0. So we have 2x is greater than or equal to 7 plus 5 is 12. And then to get x by itself, you're going to divide both sides by 2. And so I get x is greater than or equal to 6. So what that means is this. That means that any number greater than or equal to 6 is a solution to this original absolute value inequality. See, that's an R statement right here. So any number greater than or equal to 6 is going to work. So for example, try 7. 2 times 7 is 14. 14 minus 5 is 9. The absolute value of 9 is 9. And 9 is greater than or equal to 7. So far, if you look at this in terms of a number line, so far we found one part of our solution. That's a positive 6. We found one part of our solution. And notice there's an equal sign here. So equal to 6. That means that 6 is a solution. 2 times 6 is 12. 12 minus 5 is 7. The absolute value of 7 is 7. And 7 is greater than or equal to 7. It's equal to. And so therefore, you're going to put a bracket going to the right. Now let's look at this one. We're going to add 5 to both sides. Negative 5 and 5 is 0, so I get 2x is less than or equal to negative 7 plus 5 is a negative 2. And then to get x by itself, I'm going to divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. And this time I also notice that my solutions are also going to be any number, any real number that's less than or equal to a negative 1, because negative 2 divided by 2 is a negative 1. So if I go here and shade in the solutions, notice the bracket because of the equal sign. Negative 1 is a solution. Whenever you see an equal sign, that's going to be a solution. Check it. Oops. 2 times negative 1 is a negative 2. A negative 2 and a negative 5 is a negative 7. The absolute value of negative 7 is 7. And 7 is greater than or equal to 7. It's actually equal to. And you shade to the left. All right, so any solution that's here and any solution that's here is a solution to the original. So remember, this right here is a solution to this linear inequality, but it's also a solution to this. Same thing here. The solutions here, any number less than or equal to -1, is a solution to this linear inequality, but it's also a solution to this, which was our original. So the solution to the original would be, here's the graph, in terms of an interval notation, you always go from left to right. You would say in parentheses, negative infinity. Remember parentheses and, infinity and negative infinity, you always going to use parentheses. So negative infinity to -1, bracket, because remember -1 is a solution, union, and then 6 bracket to infinity with parentheses. And so that's your solution. So you have negative infinity to -1 bracket, union bracket 6 to infinity. Okay? All right, so again, don't confuse solving an absolute value greater than like you would an absolute value less than. Okay, they're set up differently. All right, so that is it. That is the key to the in-class activity on absolute value equations and inequalities.